asteroid Dimorphos was picked because of three factors: its size, its orbit, and its distance. For its size, it was around the size of an asteroid that could threaten Earth. Its orbit was due to the fact it could be determined if its path had changed by comparing it to where it was orbiting. Its distance, it was close enough so it could be easy to observe using Earth telescopes. SpaceX was chosen to launch this mission because they won the contract based on the competitive price they were charging, their experience with payload delivery, their launch schedule lined up well with NASA's timeline, and SpaceX and NASA have worked well together in the past. How much did this cost? The total project was around $400 million. Around $308 million was spent on research, $68 million was paid to SpaceX, and $16 million was the estimated cost for the final year of study. Program. One of its focuses was planetary defense, which is protecting the Earth from incoming asteroids and being able to move away from a reliance on our atmosphere to protect us from the asteroid threat. The detection system was also a part of the New DART program, which allowed us to more easily identify problem asteroids and be able to pinpoint where they are exactly. On September 26, 2022, DART successfully made impact on the asteroid Dimorphos. The DART mission was considered a success in its goal, as NASA was able to confirm the asteroid Dimorphos was slightly altered off its current trajectory. As proof the kinetic-based deflection methods working, we now know how successful of an impact we can have with such a small device. With further testing, we can fully grasp the scope of our success, such as studying how small we can make the impactor. The DART mission is an example of a great temporary measure to use as we develop other, possibly greater methods, which we can only know by testing them, just like we tested the DART mission. We can use the success of this test to hopefully help get more funding from the U.S. federal government to be diverted into NASA, so we can possibly target larger asteroids with better methods to help save Earth one day from an extinction level event. What else besides the DART mission could we use? One of them could be focused solar energy, which is the idea of converting solar energy into electricity and then using that to divert an asteroid, or redirecting solar energy to a fixed point on that asteroid. Another idea is to use a nuclear explosive device, which is essentially detonating a nuclear device nearby the asteroid, which the ensuing blast can cause the asteroid to be pushed off course. We gotta make sure we don't blow it up too close to the Earth or the asteroid in order to avoid either the radiation or the asteroid breaking into smaller pieces to hurt Earth more. Another proposal is the idea of an ion beam shepherd, which is a small satellite orbiting Earth which is capable of towing an asteroid away from Earth. But this method is both slow and time consuming.